I'm Rohil, and this is my colleague Prakhar, and we'll be talking about how we basically made the data available to everyone in GO-JEK. So, yeah, let's start with it. So this will be what we'll be talking about mostly. We'll give you a little background about GO-JEK for people who don't know, and little about Daggers, which is the product, which is the application on top of Flink. Then there's a DIY portal around it, how we did the alerting and monitoring, and what was the impact. Okay, so for those of you who don't know GO-JEK, GO-JEK is a super app. So basically we have multiple products on the app, like Go Ride, Go Food, which means that you can hail a bike taxi or a car taxi, or you can order food and you can get it delivered at your place. There are also lifestyle products like massage and etc. etc. So all these products are there in just a single app. That's called GO-JEK. And so around the statistics, we have 18 products, 3 million orders, 1 million drivers, and 500 microservices. These are just for the Indonesia market, and we have also launched in Vietnam, as well as we will be launching in Thailand. Stats around those are not here right now. Okay. So as I was saying, we were already ingesting data into a Kafka, and basically we had all the data in Kafka, but the only use cases around all of that data was for the application use cases. Basically, people were using raw data only for like showing booking history or stuff, which is like raw. They weren't aggregating. They weren't using it for as a meta help to their applications. So this was basically the data pipeline at that moment. People were pushing data to Kafkas, different kinds of data like booking, travel location pings, API logs, etc. They were being pushed to different Kafkas. Mainstream, which is the one which we use for booking flow. Appstream, which is very low latency, high throughput Kafka. And Logstream is for the location pings. And Logstream is for API logs. So all of this data was being ingested into Kafkas. We had all this data, but we didn't, not everyone knew how to use it. Specifically, only the developers were using this. They were writing their own consumers and consuming it into their microservices. So basically, yeah, for data consumption, they used an application call that we developed on our own called Firehose, which can put your data into a relational database onto a HTTP endpoint, or can just print into logs for your own analysis or just looking through the data. And it could also push to a time series database like Influx. So yeah, we had all that, but all of this was mostly around raw data. We wanted them to play with data. We wanted them to aggregate the data, get some analysis out of it. So for that, what we did was we developed a data aggregation pipeline. We started with just one use case, and that was the first use case for dynamic search pricing. So what's dynamic search pricing is that in an area, the demand and supply varies with like the day, the time, right? So we wanted to create something so that we can change the price accordingly, so that the drivers there can get this benefit because of the demand there. And we also wanted to let the drivers know that this is the place right now where you should be if you want to earn like more or such like that. So what we did was we hand coded 2 Fling jobs in 4 weeks, which were for demand and for supply. Yeah, and we put it to production. We took 4 weeks, and yeah, there were once we put it into production, people were out with 20 other use cases. Like we also want to use real-time streaming, data aggregation for solving our use cases. So yeah, we thought that taking 4 weeks again for other 20 use cases does not make sense. So we went and created a DIY platform. Yeah, so this is what we did. We created the Fling jobs. We reflected on them. We generalize them so that everyone can use without themselves having to spend 4 weeks creating 2 Fling jobs. And then we basically applied. And we created what we call Daggers. So yeah, as the name says, Daggers is just data aggregators. Pretty simple. Yeah. So it's a very generic Flink job. We parameterized as much as we could. What it does is that it feeds, like it takes in data from a Kafka stream and all of our messages are in protobuf format. So it deserializes the protobuf messages, puts it into a table, a Flink data stream table, and then aggregates, like applies the SQL query on top of it, and aggregates the stream and sends it into a sink. So this is like the flow. Consumes protobuf encoded data from Kafka, decodes the data, and registers a streaming table and all the UDFs around it, applies the SQL and generates a result, sends it to a sink. So right now we have 2 sinks, Influx and Kafka sinks. So we're gonna talk about these sinks later in the presentation. Okay, so yeah, we basically use the power of Flink SQL to get out of creating multiple jobs. So now we just had to, the parameter, we just had to set the SQL parameter into whatever desired manner we wanted, or not just we actually, all the other people, whoever wanted to use this, they could like just write a SQL and know which topic they have to consume from Kafka, and that's it. Yeah.
Yeah. So once we created this generic job, like we wanted the users, like business analysts, different PMs, to come with all those use cases that Rohil mentioned, like to create their own Flink jobs, like without our intervention, like without us like hand coding those jobs. So we wanted a DIY solution for that. So we basically created a web portal. We call it Atlantis. So what Atlantis allows you to is basically for any user, if you want to create a Dagger, so you just have to select your proto schema, and it will filter out all the Kafka topics which belongs to that proto schema, and then you can just write your Flink SQL and the UI itself, like select whatever fields you want to select, and write your the aggregation window duration, and some advanced configurations, like you can set the watermark interval and the watermark delay on the UI itself, and then it will deploy a Flink job. Yeah. So what Atlantis is underneath is basically we are using Flink's monitoring REST API. So on the UI itself, you can create a Dagger or edit its configurations and redeploy it, or you can see the status of the running jobs. Is it running, or it has been canceled, or you can stop any running job. Yeah, so this is like one of the sample queries that it has been written by one of the business analysts. So he's basically trying to calculate the demand in a particular city per vehicle types. Like as you mentioned, like we have bikes, we have cars, and we have bluebirds. So per vehicle type, and in particular S2 ID. So this is, as you can see, this is a user-defined functions. This basically takes the latitude and longitude and the S2 ID label, and it converts those lat longs to S2 ID. So it will basically give you the demand in a particular area. Yeah, so when we initially started this platform, we started with only one Flink cluster, like as there were like few use cases. But as like more users were coming to the platform, so they were writing ad hoc queries. So which was leading to like some of the ad hoc queries were taking like a lot of resources, so which was impacting some critical Daggers. So we basically wanted to decentralize this. So we basically come up with a solution, like we provided each and every team with their own Flink cluster. So that so now how it happens is like so there's a playground cluster. So people create their jobs and then try out different queries in that playground cluster. And if they are satisfied with the results of the query, then they promote it to their own cluster so that they can they can take it to production in their own cluster. Yeah, so with these different clusters, we also provide them with a basic monitoring dashboards on Grafana so that they can set up their own alerts on Grafana for their critical Dagger use cases. Yeah, so these are the screenshots of our web portal basically. So here you can see all the clusters that I was talking about, the different Flink clusters for different teams. As you can see, allocations, fraud, systems team, security team. So they have own clusters. Inside the clusters, you can see all the Fling jobs running and like what are the topics they are consuming from and like who created them and what is the status and all that information. So suppose you want to create a Dagger, so this is the flow. So this is you have to just fill this form. So you can just write the name for your Dagger, and then you can select your proto schema. After selecting your proto schema, it will filter out all the topics that belong to that proto schema. So suppose this user has selected driver location log messages. This is basically the driver pings coming from the driver app every 10 seconds. These are the locations of the drivers. So he has selected the driver location ping. After selecting this, the user can just write the SQL. So he's basically trying to get the distinct count of the drivers per S2 ID and with particular driver status, like if he's available or he's offline. And so this distinct count is, as you can see, this is again UDF, which will give you a distinct count of the values. And you can set the watermark interval and watermark delays and parallelisms in advanced options. So this, after preview, it will just deploy a Fling job. And this, like from here itself, you can, like, this will just, you can visualize the data coming so this is basically put data into an influx. And from the influx, you can visualize the data, okay, the result is coming, so the job is successful and the data is coming. So this is just to give a sense of that, okay, the job is successful to the user. So this is just for visualization. Yeah. So this gives that, okay, the Dagger deployment was successful. So data syncs. So currently, Dagger supports only 2 data syncs. One is time series, which is basically the influx sync, and the Kafka sync. So you can basically publish back to a Kafka topic. The aggregated data you can publish back to a Kafka topic. So why time series data? So it basically gives you, so this solves all the monitoring use cases. Suppose you want to monitor, okay, what are the bookings happening, how many bookings were created, how many were canceled, how many completed, and what is the conversion rate. So all these monitoring use cases are solved by the influxing. So you can just publish this aggregated data to an influxing and see all the graphs on Grafana. Yeah, so this is like one of the graphs. So here, basically, you can see all the bookings per service type. So like service types being the bike and car and Bluebirds itself. Second one is Kafka sync. So that one solves the monitoring use cases, but for application use cases, the flow is, so you create a Dagger, then you publish it to a Kafka again. And from Kafka, we have the application that Rohil was talking about, Firos. So Firos basically is a consumer that can consume from any Kafka topic, and it has different syncs. So once you publish the aggregated data to Kafka, then you can push it to some gRPC service or HTTP service or a relational database, or again to Influx or Cloud App. So these are the supported syncs in Firos. So architecture is like that only. So as Rohil was mentioned, so different teams publish data to different Kafkas depending on the type of data. And then on the Atlantis, you can select, okay, what are the topics, what is the proto, and then you can deploy a Dagger. And from Dagger, there are 2 syncs, influx, and again to a Kafka, a separate Kafka cluster. And from from that Kafka, using Firos to services, relational databases, and Cloud apps and log syncs. Atlas. So for the influxing, so once the data is in influx, so Atlas is like our own built geospatial visualization platform. So this is basically to give you an idea on a map, okay, what's happening in which area. So this is built by us, so you can get the actionable insights. Okay, in which area the bookings are being cancelled, okay, and which area the food deliveries are being cancelled or the merchants are closed. So you can get a sense out of data, okay, what's happening in which area. So you can just deploy a Dagger and it will publish to Influx, and from Influx you can visualize it on Atlas. So it'll just give you a GIF of Atlas, so you can select, and it will show you, okay, what's happening where. Yeah.
So yeah, these are some of the stats around once we were ready with the DIY portal. These are the stats for the number of Daggers that we created. 1K plus Daggers. So that's like 1K Fling jobs. We never could have done it without a generalized Fling job. Yeah, definitely. So we have 6 Flink clusters right now that are being used by people. Apart from these Flink clusters, we also have some test clusters where we, like send the people for like A/B testing and also like for some new features that they want to try, or the dev cluster for ourselves, for the team. Yeah. So most of these daggers are actually created by analysts. So who refrain themselves from writing Java code or like using Flink libraries. So like it was so easy for them to write SQLs, and trust me, the sample query that he showed was the simplest one of all of them. Like we have seen something that we take half an hour to understand what exactly is going in that query. So they're being creative a lot. Some of the, like, I could give you an example, are conversion rate daggers, monitoring the ETA performance. So, like for giving out the ETAs, they have an algorithm, and to check how it's performing, they have created daggers. Apart from that, the surge itself, they're checking what happens if we have historical data and we run surge algorithm on top of that, and then they like monitor how well the performance is right now. Yeah, and the dashboards created by the analysts are used by operation city heads. So all the city heads in like Indonesia, Jakarta, all the cities, they actually look at these dashboards and help like the drivers as well as like us improve the algorithms, like the search or the ETA ones. Yeah. The second thing was 2 minutes to production. So yeah, again, like we went in 4 weeks. Now this just takes 2 minutes, and that too just all the analysts and the project managers. Those are the ones creating, and they just take 2 minutes to fill up the form, and it's done. It's started. 1+ terabyte of data processed every day. So yeah, so right now, like every day into our Flink clusters, we're pushing 1+ terabytes of data that people are using directly from Kafka, and they're like using for their different use cases to Kafkas or for monitoring to Influx. So we come to deployment. As I said, like we started with Flink clusters on Yarn, and right now, like most of our clusters are actually on Yarn, and we have started shifting to Kubernetes with the new versions of Flink. And yeah, similarly for deploying on Yarn, we use Terraform for setting up the machines and all on Google GCP and AWS. And for provisioning, we use Chef. So that actually reduced a lot of time for provisioning and all, but still it takes a lot of time because you need to run the Terraform, and then it needs to run Chef on its own. So it takes time. So that's why like we wanted to move to Kubernetes, which takes no time. Like single Helm chart for all the clusters. You just parameterize the release name, done. And checkpointing. For Flink clusters on Yarn, we have it on HDFS. That's the underlying thing that's behind Yarn Resource Manager. And for Kubernetes, we are using Google Cloud Storage when we are on GCP, and on AWS, we are using S3. We also wrote a small Dagger Kubernetes controller. So what it basically does is that whenever in some case, if the job manager restarts, Flink's job manager, the job jars are actually cleared up. But we wanted them to be available always so that our portal can just use the REST APIs to run a job on it. So what we did was that we wrote a small Kubernetes controller that looks into if the container is killed or if the pod is deleted. Then once it comes up, it keeps on pulling it till the REST API comes up and pushes the job jar, uploads the Dagger jar onto it. So this makes it like the jar available all the times on the Flink clusters. It also scales the clusters when more slots are needed. So yeah, what it does is that it just polls the number of slots available using the monitoring REST API, and in case if the slots go beyond a specific threshold, which is different for different clusters, like considering the parallelism required and all. It just scales them to go beyond the threshold. Yeah, that's one of the things. And yeah, this is a diagram explaining exactly where things are. So most of the things are actually in Kubernetes, which includes the Atlantis, the DIY portal, the Dagger controller, Flink itself. Daggers runs on top of Flink. And for monitoring purposes, we have Telegraph, which runs as a statsd server, and which listens to all the events that are being sent by Flink. So Flink has a statsd jar. There's a Flink statsd jar, which we use for sending all the metrics to Telegraph. All these things monitoring can be seen on Grafana, as he had shown the graphs. Yeah, that's it. Okay, so this is a small dashboard for our Flink uptime alert. So we have alerts on top of this. So this one is for us, so that we can know if the cluster is down or anything, and for how many days it has been up. And yeah, this is for the machine details. Again, all of this just uses the Flink statsd metrics. That's it. Nothing else is required for doing this. Alerting. So we have alerting on top of all the jobs that people create, as well as for the clusters. So for any job that a person creates, he can just opt in for alerts, and he can give his PagerDuty handle and the or the Slack handle, so that, or the channel on which he wants the alerts. And Atlantis will just set up the tick scripts so that it can push all the alerts there. Users are provided with a health dashboard as well. There's a very generic Grafana health dashboard, which is a parameterized one, templatized one, so that we just generate a link on Atlantis that shows you Grafana health, basic the uptime of the Dagger, for how long has that job been running on Flink cluster, and how many messages has it consumed till now. All the stats around it. Yeah, alerts are sent to specific teams via the Slack channels and PagerDuties. That's it. Impact.
Yeah. So after creating this DIY platform, so what was the impact? So here are some of the examples of the use cases solved by different business analysts and PMs. So first one is API monitoring dashboard. So for all the APIs, as we mentioned, we are having around some 500 microservices. So we have all this data, all the API logs into one of the Kafkas. We call it Logstream Kafka. And from that Kafka, people have created Dagger jobs, and which has helped them creating a dashboard. So for we can monitor how many 500s were there, how many 400s were there, how many 200s, and they have set up their own alerts. So if the 500s goes up, they send it to some PagerDuty or some Slack alerts. So this is basically we are processing around 5 billion events per day. Another one is the demand and supply, as Rohil was mentioning. So around 44,000 geolocation points. So what are the demand and supply around all those points, so we can have a search pricing on all those geolocation points. Another one is allocation metrics, so as I was mentioning. So all the allocation metrics, as in what are the bookings created, how many are completed, how many were being completed compared to the last week, and what is the conversion rate, what is the acceptance rate by drivers. So these come up around 25 plus metrics. Last one is user segmentation. So this is a separate product. So what we do is, so this is called tag store. So what we do is, on the base, this is first step towards our food personalization. So what we do is, on the basis of what a user has ordered, we tag that user. Suppose somebody ordered a burger, so we'll tag that user with burger, and similarly with any food item. And we'll allocate vouchers to only those segment of users when we are doing the merchant promotions. So this is with Daggers, what Daggers will help in this is, so we can actually tag the users real time. So as soon as somebody orders some food item, we tag them real time. So this has basically helped us in 26% more conversion rate in our food orders. So this was the impact, what we have solved with this platform. Yeah. this was it.
Any questions?
Any questions? We're a bit ahead of schedule. All right, if there's no questions then, please join me in thanking Rohil and Prakhar for a very interesting talk.
Okay. Good.